Okay, now we have this diagram which shows a free pistol. Now, as the question earlier said, this is a pistol of two diameters. We have the external diameters and the internal diameter. Now, the internal diameter is 85 millimeters. So our given parameters, we have the internal diameter to be 85 millimeters. When we convert it, we have 85 times 10 raised to the power negative 3 meters. We have our external diameter. This is internal. We have our external diameter to be 100 millimeters, which is 10 raised to the power negative 1, which is 0.1 meters. So this can be 0.085 meters. So we have that. So now take note, they say that the total length of the pistol is 500 millimeters. But now when we push the pistol from the point of end to the other side, you notice a sudden seize at 150 millimeters to the end of the pistol. This is the end that is closed. This is the end that is open for the movement of the pistol. Now, when it is moved from this end, this closed end, to this part, towards the end of the movement of the pistol, notice now this dimension is not to scale. It is not to scale. This is like a representation that shows the question. I believe what would have caused a sudden cease in this question is due to this. I noticed that what should cause this ceases, this place is closed. More of like the size of this cannot pass through here. Very, very important. So now it is closed. It's going to cease at 150 millimeters to the end, meaning that the other side is 350. Very, very important. So that is very, very important in this question. So now they say we should calculate what the positive and the tensile and the compressive stress in this pistol. Now, first of all, now the given parameters they give us, the full length of the pistol is 500 millimeters, which is in term 0.5 meters. Very, very important. Now they give us the kinetic energy of this pistol, which is 0.004 kilojoules. Now kilo is 10 raised to the power 3. So we have 0.004 times 10 raised to the power 3. So we're having 1, 2, 3. This is going to be left with 0.4 joules. So we are given the modulus of the free pistol or the bar. So we are having the modulus to be 200 times 10 raised to the power 3. So we have 3 Newton meter per square meters, or Newton meters, Newton per meter square. So it's very, very important to calculate the length of the stroke or the stressed part. Now take note, the length of the stressed portion of this cylinder, the length of the stressed portion is this length that is going through movement. So take note, this has been stressed. So the length of the stressed portion is, we're having the length of stressed. Okay, isn't working. So we're having the length of the stressed portion. So we're having portion. So we're having the length of this cross section as L of the stressed. Now it is 0.5 negative 0.15. This is 0.35 meters. This is so we're having the length of the stressed portion as 0.35 meters. So this is the length of the stress portion. Now this is the stress portion, the movement of this point to this point. This is the part that has been stressed. What will be the area of the stress portion? Now the area of that stress portion, area of stressed portion. Now take note, we're having two internal and external diameter. Anywhere we have internal and external diameter, the area will be the external minus the internal. All of them will have integral square over 4. So we'll do that, we have pi, which is represented as 3.142 over 4. Having brackets, we have this as 0.1 square negative 0.85 square. Now this will give us 0.00217 meter square. So this is the area of the stretched portion. This is the area of the stretched portion. So it's very important to take note of this concept that we have the area where we have two diameters. It will be this formula. Now the area of the stretched portion is this 350. This is the, take note, you're pulling the piston from this point to this point. You have stressed this portion of the cylinder. Is that understood? So that's why we have this. I'm emphasizing on this because of I feel that this is where the concept is. From the length stress portion, we have the area of what? The stress portion, which is, in terms of area, I'm talking about this and this of the two diameters. Now, so take note that we say that the kinetic energy is also equal to the strain energy. The kinetic energy is equal to the strain energy. Now, the energy due to straining is also energy due to movement. So that's the relationship between cases like this, which is energy, the ability to do work. So the work due to straining is the work due to motion, which is kinetic energy. So we have Ke is equals to the strain energy. We will say that is equals to what? The stress square, the area, the length, all over 2E. So when we have this, we're going to put our values. Now take note, they say we should calculate what? The tensile and compressive stress. The tensile and compressive stress is gotten by making this subject formula. So we are having this square is equals to, we're having 2E Ke all over A multiplied by L. So we're having 2 multiplied by, we have this as 200 times 10 to the power 3. Is that 3? Yes, I think. Let me get on the question. Yes, 10 to the power 3. We have our Ke as 0.4. So we have over our area, we got our area to be 0.00217 multiplied by our length. We got our length to be 0.35. So we have the square of the stress. Perform arithmetic operation here. We're going to see that this is going to give us 2.09 times 10 raised to the power 9. So this is the expression in terms of the stress square. So we have this by taking the square root of both sides. Take the square of both sides. We have 2.09 times 10 raised to the power this. So we have the stress. Now, anywhere you take the square root, you're going to have either positive or negative values. So we have plus minus. The square root of 2.09 times 10 to the power 9. Now this will result 4.5.7 times 10 to the power 3. Now this is going to be giving us 4.5 45.7 times 10 to the power 3. 10 to the power 3 is kilo, so we have this as kilo per meter square. So this is plus minus. So now to answer that question is to say calculate the tensile and the compressive stress. So we're having plus negative. So the tensile stress is equals to, so we have the tensile 45.7 kilonewton per meter square. So we have tensile. So we have the compressive, given us 45.7 kilonewton per meter square. So this is for compressive. Now you can denote this by either a negative sign here and a positive sign here.